Good afternoon, everybody. I'm Dr. Gray. I am one of your lab coordinators for Gen Chem 1 1141. I wanted to introduce you to experiment number 2, that's lit. I titled it that to be hip. So what this is all about is this is an experiment in which we're exploring whether or not a solution can conduct electricity. And so what you're going to have to use to evaluate that is you're going to use a 9-volt battery, a light on a strand, and a copper wire. What we're going to be looking at is really illustrated right here very well. We're looking at these 3 different kind of permutations or combinations of substances. This guy right here, where we've got red balls and blue ones that are separated from one another, not connected at all. None of them are connected at all. None of them are attached to one another. Then we've got this right here, green and yellow, in honor of the Green Bay Packers, where there are some that are connected and then some that are free by themselves. And then over here, where we've got what looks like purple and kind of grayish, where all of those are together. So this is kind of a spectrum: no contact, some contact, all contact. And what this illustrates is the difference between a strong electrolyte and a non-electrolyte. So a solution that can conduct electricity very well and one that cannot conduct electricity at all. So what you're going to be doing is you're going to be looking at a couple of different compounds. You're going to be looking at sodium chloride, your standard table salt. You're going to be looking at calcium carbonate, CaCO3, which is the material that's used to make chalk. And then you're going to be using sucrose, which is a sugar. So what we're going to be exploring with this experiment is we're going to be exploring, does something conduct electricity? Does something dissolve in a solution? And another term for conducting electricity is it's an electrolyte, and strong electrolytes dissociate from one another. So it's an ionic compound that dissociates from one another. Dissolve and dissociate are not exactly the same thing. There are some things that will dissolve in a solution and they will not conduct electricity. So it will dissolve, but it will not dissociate. Then there are other substances that will dissociate and dissolve. And so what you're going to be looking at is you're going to be looking at you're going to be looking at these different solutions. Then you're going to be looking at molar calculations. So calculating the concentration of a solution. And to illustrate that, I'm going to show you an example right here. So as an example, let's say you had a solid of NaCl. So let's say you had 3.60 grams of NaCl, and you dissolve that into, let's say, 75 milliliters. Okay, now in order to figure out what is known as a molar concentration, you need to figure out how many moles of this NaCl is in the volume in liters. So in order to do this, you have to do 2 conversions. The first one is you have to convert the grams of NaCl into the moles of NaCl. So we'll say 3.60 grams of NaCl. Now, the next part of this dimensional analysis is you have to know the molar mass of NaCl. And you can get that from the periodic table. Look at the atomic weights of each substance. And you would see that the molar mass of NaCl is 58.44 grams. And that's 1 mole. So 1 mole of NaCl, it has a mass of 58.44 grams of NaCl. So what we'll do here is say 3.60 divided by 58.44. I'll plug that in my calculator. 3.60 divided by 58.44 equals 0.0616 moles of NaCl. Okay, now that number of moles we're going to bring over here. So the second conversion is a little simpler. We have to convert our volume, which right now is listed in milliliters. We have to convert that into liters. So how do we do that? We would say 75 milliliters. And we can set this up as a dimensional analysis and say that there are 1,000 milliliters in 1 liter. So 75 divided by 1,000 is going to be 0.075 liters. So I'll bring this number right over here. So now to do this calculation, all that I have to say is 0.0616 divided by 0.075. And our concentration for this solution, based on this mass and the total volume, is 0.821. And then you use the capital M to indicate molarity. Okay, so you're going to have to do that sort of calculation for all 3 of your solutions. You're going to have to figure out the molar mass. You've got a periodic table. If you get your lab manual, you flip to the very back. You see this beautifully constructed periodic table, and that has all of the information that you need. So you can use that to calculate their molar mass. Then what you do is you determine the volume that you used, and that'll do it. All right. Well, I hope this is helpful, and I hope that you have a good time in lab, and let me know if you have any questions. Have a good one.